Welcome to Brain Vision.
Hello everyone, this is the solution to problem 30, chapter 24 of God Knows Physics. So in the first part of the problem, we're asked to find the electric and magnetic forces on a charge of 2.6 times 10 to the minus 8 coulombs in an electromagnetic wave that has an average intensity of 2.5 times 10 to the 3 watts per meter squared. So how do we find the electric field? Well, the electric field, or the electric force, sorry, F E is equal to Q times the electric field. And so first we need to find what the electric field is, or we need to express the electric field in terms of the intensity. But we know that S bar is equal to C epsilon 0 times E R ms squared. And so rearranging this for E, we find that E is equal to, or ERMS, which for the purpose of this problem, it's going to be synonymous with E. So we have S bar over C epsilon 0 square rooted. So this is the value of ERMS. We're not going to work it out just yet. Instead, what we're going to do is realize that the particle is going to be sitting here and the electric field is going to be pointing up. So it doesn't really matter in which direction the electric field is pointing. It's going to be either pointing up or down, but the magnitude of the force is what matters for the purposes of this question. So we're going to say that the electric force is equal to, it's going to be equal to Q times the square root S bar over C epsilon 0. And so when you work this out, you find that the solution is 2.5252 times 10 to the minus 5 newtons. We're also asked to find what the magnetic force is on the particle, FB. FB is given by Q, so charge times the velocity of the particle cross-producted with the magnetic field, B. But since the particle in this part has no velocity, this is 0 newtons. So this is the solution to part A, this is the solution to part B, and now we're going to add the velocity to the particle. And so we're going to have a velocity of the particle that's moving perpendicular to the magnetic field. So the directions are over here. So electric field is moving on the vertical. The magnetic field is moving into and out of the page, and the velocity is moving left perpendicular to both the electric field and the magnetic field. So the electric force, Fe, is completely unaffected by the fact that the charge is moving. So again, this is just QE RMS. So it's the same value as we had before. So it's 2.52 times 10 to the minus 5 newtons. But now the magnetic force is going to be different because the particle has velocity. But now, since the particle is moving perpendicular to the magnetic field, in the cross product, we can actually drop the sign factor. So we would have, so we're just going to have Q times V times B. But but we don't know B as of yet, so we need to find what B is. But we do know that E RMS for an electromagnetic wave is related to the RMS magnetic field through this formula. So from this, we can work out that B, which is going to be equivalent to BRMS for our purposes here, is equal to ERMS over C. And so we can put all these values in now, and it's Q times V times over C times E R and S, which again, substituting in the value for ERMS from this part over here, is just going to be Q times V over C times the square root of S bar over C times epsilon 0. And the force works out to be 3.11 times 10 to the minus 9 newtons. So these are the solutions to part C and part D.